In this talk, we present our work, Omni-DETR, Omni-Supervised Object Detection with Transformers. This is joint work with Pei, Hao, Gru, Nuno, Bernd, and Stefano. The standard object detection annotation is the bounding box coupled with the class information. However, this standard detection annotation is very time-consuming and expensive. For example, the complete annotation of a single Coco image takes about 5 minutes. The question is, do we need accurate and complete annotation to achieve strong detection performance? There are many weak object detection annotations, points, tags, counts, for instance, but they are not well explored in the literature, and the majority of the detection frameworks are designed to be used with complete annotations. One of the main reasons for this is that using weak annotations doesn't have much benefit yet. For example, in UFO Square, the first Omni-Supervised object detector, using additional weak annotations only has marginal gains, like 0.3 points when adding 80,000 images with tag supervision, or 1 point with point supervision. These are not very promising. However, in this work, we will show that weak annotations can help to improve detection performance and achieve better cost accuracy trade-off. To tackle this problem, we propose a unified architecture called Omni-DETR, which can use different types of weak supervision or a mixture of them. It is built on a student-teacher framework. Given image, two views are generated by a strong and a weak augmentation. The weak augmented view is forwarded through the teacher to produce the detection predictions. The predictions are then passed to a pseudo-label filter together with the Omni-Supervisions to generate the pseudo-labels, which are then used to supervise the learning of the student on the strong augmented view. Unlike the previous weakly supervised or Omni-Supervised object detector, which can only address one or a few weak annotation types, our Omni-DETR can address 6 different types of weak supervisions, or a mixture of them with a unified framework. Here we show the performance of different weak annotations on the Coco dataset. The supervised baseline is on 10% of Coco data. When using additional weak supervision, non-trivial improvements will be achieved. This shows Omni-DETR can leverage different weak annotations very well. Under the semi-supervised detection setting, Omni-DETR is better or comparable with the state-of-the-art unbiased teacher. Under the weakly semi-supervised detection setting, using either tags or points as a weak supervision, Omni-DETR outperforms the state-of-the-art by a large margin. Under the Omni-Supervised detection setting of UFO Square, Omni-DETR also has a big improvement. Here we show the annotation cost in seconds per image for each type of annotation. The cost varies from supervision to supervision and dataset to dataset. For example, annotating accurate bounding box is expensive for bees and cloud human datasets because the objects are small and very crowded. However, it is cheap to annotate points for them. At the same time, annotating accurate category is very expensive for object 365 because it has more than 300 categories. But annotating only the bounding box is easy and cheap. Here is the accuracy cost trade-off comparison. We can find using mixture annotation shows better results than a strong semi-supervised baseline. For example, at the same accuracy on bees, mixture annotations can save the cost of about 15 annotation hours. At the same cost on cloud human, 4 points of gains are available. These results show that weak annotations are useful and can achieve a better cost accuracy trade-off. We hope this work could encourage more research efforts in this direction. Also, the code is available online. If you are interested, please come to our poster session.